So in question number 8, electric field intensity of a spherical conductor. Spherical conductor means inside it is empty, outside charges are present. So electric field intensity at inside will be is available. It is not available. Electric field intensity will be equal to 0 E with respect to R, and electric fields intensities are available only at the outside surfaces. So this is a graphical representation. If the same question is asking electric field intensity for a solid non-conducting sphere, solid non-conducting sphere, what will happen? Solid non-conducting sphere means your graph will be look like this one, E with respect to R. Solid non-conducting sphere means charges are present everywhere. Charges are present everywhere. Last class I told, right? In this case, charges are present only at the surface. Charges are not present anywhere. So here E is proportional to R and E is proportional to 1 by R square. If it is solid non-conducting, then this will be the answer. In that cases, option B will come, but in this question, answer is option number C. This is for a spherical conductor. Spherical conductor, or it can say solid conductor. Last class I told, right? Solid conductor. Or this can also say hollow conductor. Hollow conductor. So many options will be there. Spherical conductor, hollow conductor, and yeah, solid conductor, all this case. This is for solid non-conductor. So see the questions and depends upon that take the appropriate options out of this one, what is matches with this question expectations. Okay. Okay, so let's move to question number 9th one. So the 9th question. A hollow cylinder has a charge Q, coulomb is within it. One cylinder is given, okay, normal pipe like structures. If phi is a hollow means inside it is empty, it is just a cylinder, okay. If phi is the electric flux in units of voltmeter associated with the curved surfaces B, okay. So I can say total flux phi net will be equal to Q divided by epsilon 0. Total flux means there are surface will be there A, B, C. So flux surface number A plus surface number B plus surface number C, all together it is Q by epsilon 0. Surface number, the flux associated unit of voltmeter associated with the curved surface is B. Curved surface B is given as flux number C. And the flux, we need to find out the flux linked with the plane surface A in units of voltmeter. Okay, this is what is given. So let me read the question once again. A hollow cylinder has a charge Q coulomb within it if phi is electric flux in units of voltmeter associated with the curved surface B. Okay, B is the curved surface. A and C are same, right? A and C are same. So I just take it as flux dash, and here also I am taking it as flux dash because A and C are symmetrical circular structure, which is equal to Q divided by epsilon 0. Okay, now I'll go to the question again. Flux linked with the plane surface A. Flux linked with the plane surface A. So A means phi dash. So we need to find out phi dash. So 2 phi dash plus phi equal to Q by epsilon 0. So phi dash equal to Q by epsilon 0 minus phi whole divided by 1 by 2. So this is a flux associated with the surface number A, or this is also equal to the flux associated with the surface number C, because both are identical, and we got this answer. Q by epsilon 0 minus phi whole divided by 2. This is matches with your option number D. Your option D is the right answer for the 9th question. Okay, let's move to the 10th question. If EA be the electric field strength of a short dipole at a point on the axis, and EE be the equatorial lines at the same distance. So with respect to a dipole, A be the axial electric field. What is the formula? K into 2p divided by x cube. So we have minus q and plus q dipole will be here at a distance of x from the center. This is a formula. And with respect to equatorial, it is what's the formula? Kp by x cube. So minus q charge and plus q charge, we are finding electric field will be here. And this electric field is given this one. What's the direction of this electric field? Along this direction. What's the direction of this electric field? Like this. Here the minus, it is plus. So dipole moment is in this direction, electric field is like this. I told the angle between electric field and dipole moment in the previous videos, it is 180 degree. Here angle between electric field and dipole moment, both are directing in the same direction, and it's making an angle of theta. So E and P theta equal to 0 degree. Here E and P theta equal to 180 degrees given. So I can say axial electric field equal to 2 times of E equatorial electric field. So this is matches with your option number B. Option B is the right answer for question number 10. Let's move to the next question, question number 11. The positive charge of equal value Q are placed at the vertices of an equilateral triangle. So Q will be here, Q will be here, Q will be here. This is an equilateral triangle. All sides are equal. Resulting lines of force should be sketched as in. So which of the following is a correct statement? That's what. So here we need to know the properties of electric field lines. What are the properties of electric field lines? Electric field lines will never cross each other. Electric field lines will never form a closed path. So there are a lot of rules will be there. So based on the rule, we'll see number 1, first option. It is like a seed like structures, right? And the lines are also get closed. So that will never become an answer. Second option, electric field lines are always emerges from positive charges. Always emerges means this all are positive charge in the question. So the electric field lines are always emerges from positive charge. Always emerges from positive charge like this. So this will always emerges from positive charges. So like this. Starting from here, 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 never cross. So it should go like this. Starting from here, starting from here. This is the lines of force. And if you look into option number B, this is more or less similar, but if you see, it is some of the lines, it is not touched on the charges. It should touch on the charges. It should touch on the charges. So B is not touched on the charges, so it is not the correct answer. If you look into C, perfectly matches with them. So answer is option number C is the right answer for this question. If you look into option number D, again it is a circle closed path that will never comes as an answer. So option C is the right answer for question number 11. Move to the next question, question number 12. Question number 12. What is question number 12 is specifying? 3-point charges Q1, Q2, Q3 in the order are equally placed along a straight line. Q2 and Q3 are in equal magnitude but opposite sign. If the net force on Q3 is 0, the value of Q1, Q2, Q3 are placed on order equally placed. So let place Q1 and Q2 and Q3 are equally placed. So I take the distance as a meter or x meter, whatever. So but one condition is given. Q2 and Q3 are equal in magnitude but opposite sign. So I can say Q2 is equal to Q3. Okay, Q2 is equal to minus Q3. If Q2 is plus Q, then this become minus Q. That is the understanding. Okay, both are equal magnitude but opposite sign. So I replace the diagram like this one. Q1, Q2 I am giving positive sign and Q3 I am giving negative sign. Distance is still same, a meter. What's the question is asking? The net force on Q3 is 0. Value of Q1. Net force on Q3 is, this is our Q3. So net force on Q3, we'll see what all the forces are acting on this Q3. Okay. Because of the first charge, this is a near charge. This body will attract towards this one. Okay. What will happen to this one? This is a Q1 charge. We don't know whether it is positive, whether it is negative, I don't know. So to have a net force, definitely you have to remember, to have a net force on this charge equals 0, already one force will be here. So to have a net force on that charge is 0 means other forces is acting in this direction or in the opposite direction. Already one force, this is given in the question, these two, this q2 and this q3 are equal in magnitude and opposite sign. Based on that, definitely this minus q will attract towards this one. It's very clear, we can't do anything over there. But here q1, we don't know whether it is positive, whether it is negative. It is not there, it's not given in the question, positive or negative, nothing is given. But if q1 is positive, what will happen? Minus q will come again in this direction. So total force, two bodies are pulling like this means the total force will never equal to 0, right? Because one guy is pulling, other guy is also pulling. So it is not 0. It's not possible. So what will happen? This should be a negative charge. If this will be a negative charge, then this negative charge will repel. So definitely the other forces should be in the opposite direction. Two forces are equal means total force will be equal to 0. So the body in equilibrium state. Okay, total force equal to 0 is a condition which is given there. So we are make use of that condition. So first we will find this force. What is this force? K into we know one force in this direction, Q into Q. So Q square divided by A square. This if you are multiplying with the plus Q and minus Q, you will get minus Q will be here. Okay, so that minus is representing in this direction, that's all. Okay, or in another way I can say total force acting on the body. Okay, so not to confuse you, I am writing total force on Q3 equal to 0. So total force equal to Q3 is equal to 0 means body is in equilibrium or not moving. So we'll see the force due to this first one, these two. What will come? K into Q square by A square. What is the sign? Q into minus Q. So it's negative charge. Plus, what's the charge between them? Q1 into minus Q divided by, what's the distance between them? A plus A. So it is 2A, it become 4A square. So K will be here. Okay, so K will be here. So total force will be equal to 0. So K A square. Here also K A square will cancel it out. So that is equal to 0. So now I'll come one step back to here, and here I have minus. So minus Q square, that's all. K and A square is already cancels, plus the other side is Q1 into what is that? Q1 into minus Q. Q1 into minus Q whole divided by 4 equal to 0. I am taking one to the right side. So Q square will get cancelled. So here we have minus Q. This is taken to the right side. So it becomes Q1 divided by 4. So what you are getting for Q1? Q1 will be equal to 4 times of Q, you will get it. Okay. So Q1 you will get it 4 times of Q1. 4 times of Q. Next, here Q1 they are asking in terms of what is called Q3. So what we have considered? Q3, okay, Q2 is equal to plus Q. So Q3 equal to what we have considered? Minus Q. Okay, so minus Q means here I can say this charge means what? Q1. So Q1 equal to 4 times of Q means what? Q means I can substitute Q2 or I can substitute it as minus Q3. Correct? Okay, minus Q3 is minus Q. Listen, minus Q3 is minus Q. So plus, so minus Q3 is minus Q. So plus Q3 means what? Plus Q. So I can simply written as this is called Q3. Okay, I assumed Q2 is equal to Q. So Q2 is equal to minus Q. Minus Q is equal to minus Q3 is equal to minus Q. So plus Q3 is equal to plus Q. So 4Q. Q means 4 into Q3. This is matches with your option number A. So first option A is the right answer for this question. So total, if total force on the body is equal to 0 means this is our body called Q3, this is our body called Q2, this is our body called Q1. So Q3 total force we are calculating. Force due to Q2 we have written. Force due to Q1 we have written. All forces we are adding and equating to 0. That is a condition given in the question. We as a person, we obeyed that condition and we applied and we got the final answer as option number A. So 12 questions we have discussed, further also we have to continue.